Okay, so last lecture of the class. Today we'll talk about Lex, which is a tokenizer for C. When it comes to parsing, there's usually two steps to it. First is tokenizing, which involves breaking everything into the smallest bits, and then parsing is figuring out if those bits actually are put together in something that makes semantic sense, or a grammar. So you can think of the tokenizer as finding the words, identifying the words of a sentence, and the parsing is, does it make grammatical sense? Because I can put this whole slew of words together that make no sense, but they're still English words. So this is, think of the tokenizer as the first step with parsing. Okay, and we're going to talk about Lex, which is a tool for it. Go into regular expressions, which I've done a little bit of, I'm assuming, in scripting. So hopefully this will be a good quick review. All right, so the problem, parsing can be time consuming. For example, take this very basic HTML page. Sometimes I get a lot of comments saying that this is way, takes too long to parse, at least a general one. Did y'all find that to be the case, or was it not too much? Oh, good.
Yeah.
It went really fast? Okay, great. Well, good. Then maybe we won't need to do this. While you can write a parser for it, Lex can at least simplify the tokenizing step, which is the first step to parsing. And we'll get into exactly what all that is later. So what is Lex? It's a scanner generator. In other words, it is a program that is going to generate C code that can scan something else. This is where people get a little confused because this is how compilers work. Because when you write a compiler, you know what the first test case is? Compile yourself. Every time. Well, if you write a C compiler in C, your first test case should be, can I compile myself? Hey, that's what they do. First thing they do. So I know it seems like there's a little chicken and the egg you gotta get around here, but yeah, it's a scanner generator, or it's going to generate C code to help you parse something based on some specification. So you give it a specification, it generates a scanner for you. And it allows you to write regular expressions to match input. All right. So regular expression, let's see, what did Wiki say? A sequence of characters that define a search pattern. All right, great. Given a sequence of tokens, it searches for a presence that constitutes some pattern. All right. In other words, it's a specification used to see if a string or part of a string matches a pattern you describe. Okay. So what are we going to do? Overview. We're going to talk about regex, which allows us to write a specification. Well, actually, we're going to talk about Lex first. Lex is going to allow us to associate a function call with the regex. Wow, this needs to be flipped, but that's okay. 1 and 2 are flipped now. And then the collection of our regex to functions calls mapping alleviates the headaches of parsing, and hopefully I can show you how that can be used in order to simplify that whole HTML project. All right. Any questions so far? You good so far? Chris? Yeah? Okay. So I don't know if everyone's really tired right now, or this is everyone's, you know, like, this is obvious, or what's going on. Don't know. Tyler? How's it going, Tyler?
Yeah.
Yeah. So the tool we're actually going to use is called Flex, and it's because the original program was called Lex, and it was too slow, so they made Fast Lex, which is, and then called it Flex.
All right.
What's that? Yeah, it's more flexible. Yeah, yeah, that's it. The simplest way to think of it is it matches C code / functions with an associated regex. AKA, once it finds the regex, it calls your C function. That is what it does. So here's an example. This one is just going to count the number of characters and the number of lines in a piece of, in your input. So your first section are basically anything global or any headers you want to include, and each section, well, your sections are delimited by 2% signs. So first section is just I'm going to start 2 variables, num lines, num cars. And then the second section is where you have your regex on the left and what your code is on the right. So \n, aka on a new line, increment the number of characters, because a new line is a number of character, and increment the number of lines. Said that backwards, but that's okay. Otherwise, if it does not match that regex, What dot means is any character. So if it matches any character, then you just increment num characters. And then down here in main, which is what your C code would be, let's see, int main, yylex is what actually starts doing to do the parsing. It goes in and parse it. By default, it parses from standard in. You can change it by setting what yyN is. I'll show you that later on. And so you can set it up to be a file if you wanted to. So it does the parsing. Once it gets into file, it prints off the number of lines. All right. Oh, sweet, we get to go. Okay, here we are. We get to code. Fun? So let's go into make a lex. Let's go first dash L. So int num chars, and then we'll, oops. We need to start with the percent. Let's see, percent open. So backslash n 0 num lines equals 0. So on a backslash n num lines plus plus. Let's see. On everything else, num chars, and then of course we'll go ahead and do num chars plus plus. Down here we'll have int main int arg c char star arg v yylex to go ahead and do the parsing, and then we'll print off percent. I'm just going to do the two variables just to get us going. Num chars, num lines. All right. So in order to compile this, if I typed everything correctly, first you do, ooh, someone connected, nice. Flex first, premature end of file, that's not good. Did we miss a, whoa, that was not what I meant to do.
Is it because we haven't redeclared another section?
Yeah, let me go check. So, no, those two sections are there. Oh, haha, it was backwards. All right, so it says it doesn't do anything, but if you look out, it makes this lex.yy.c, which is a C file. You can look at this if you want to, but it's not going to make too much sense at first. But it's just how it generates everything. There's a lot of theory behind the scenes of what it's doing and why it's efficient. If you ever take a compiler's course, I will go into it, of course. But that's beyond the scope of this class. But just know if you try to compile it, it should give you an error. Undefined reference to yyrat. That's because you're not including the library. So let's include the library. Whoops. Which is library lex. And now it should produce an a.out. So if you actually run a.out, you go hello world, and then control D to end the program. So it says 13 characters, 1 new line. Another cool thing you could do is just go ahead and send it first.lex, and it says that one has 187 characters and 12 lines. Okay. All right. All right. That's not too interesting, but I just wanted to show you exactly what's going on. Right, Perry?
I yawn.
You yawn, I know. All right, so I talked about running it. Hopefully the interface is not too complicated. The idea is you're going to match regex to an action. Two things to keep in mind before we go forward. Lex patterns only match a character string input once starting from the top. So it's only going to match one of your rules. It's not going to try and match multiple rules. Lex executes the action for the longest possible match for the current input. So if you have two inputs that it could go for, if one is longer, it's always going to choose that. If they're the same length, it's going to choose the one that comes first in your list. All right, any questions so far? Yes. Yep. Early implementations of grep might have used this. Okay, regex, how many of y'all have done this before? A little? Okay, so some. Okay, good. So we're going to go through just a little more formally. Well, not too formally, actually. Because we're not going to talk about finite state machines and how a regex is actually put together. Hopefully you'll do that in algorithms. But at least high-level view of what's going on. Regex allows us to match a pattern to a string. For example, notice that this one, you have the solid brackets. Whenever you see solid brackets, it says it needs to match at least one character listed in here. So lowercase a to z or uppercase a to z. So it needs to match at least one of those. And the plus means it needs to match one or more. So, for example, apple, it would match because capital, those are all letters. So now I'm going to ask you, how about number 2? Would number 2 be matched with that regex?
Yeah.
Yep, all right. 3? 4?
No.
Nope. 5? How about 6? No, because it has to have one character. That plus means it needs at least one character. And the last one, apple, banana, superfly. Who doesn't like that? All right, good. Okay, plan of attack. There's 3 basic tools to create it, and then I only list 2. Wow, that's classic. Wow, that's hilarious. Yeah, the third one is grouping. Grouping. There, I said it right. Whew, that was close. We'll get to that, I guess, later on. I'll need to update this. Symbol matching. This specifies what symbols you wish to match. Example, A through Z, match any lowercase character. And then you have a quantifier, which tells you how often something must occur. Ignore that leading backslash. That needs to be gone. But a string with one or more word characters, aka uppercase, lowercase, or digit. And that plus means one or more of them. All right. And the last one is grouping, where it basically says this group has to exist, followed by this group, followed by this group. It's just a way to help you organize things.
You can specify the size, like how many characters are required. Like,
Yes,
say
we're going to
not-
go into each of those a little more depth right now. This was high level to give it to you what the idea is. Now for symbol matching, these are the common ones. By the way, when you do regular expressions in Lex, pretty much all implementations implement the Lex specification. So anything you learn here should go over to Java, Python, Perl. What language? Any other scripting languages y'all are using? Oh, PHP. I meant in scripting. Who's in scripting? Or do you know? JavaScript as well. Yeah. Okay, great. Bash. Yeah. So all of them are going to use the basic Lex. They'll probably add a couple more features to it because they want to be fancy. But they're all going to implement this. So this is actually very important to learn. So regex, there are numerous options. Here's a good starting list. Something to start with. So dot matches any character. Keep that in mind. So anything can be a dot. That caret followed by regex, then must be at the beginning of the line. So the line must begin with this regex, is what it's saying. And then you do regex $, finds regex and match at the end of the line. So you've got beginning and end. Of course, if you want the whole line to be something, you put the caret, regex, $, and then the whole line has to match that in order for it to work. ABC, set definition, can match the letter A, B, or C. Notice that you can put those next to each other. So ABC followed by VZ. So any combination of that. That'd be 2 characters, first one ABC, the second one has to be B or C. Okay?
So with that one, the ABC, VZ, that's A or B or C?
Right.
Okay.
So you have 2 characters, first one has to be A, B, or C, the second character has to be B or Z.
Okay.
Okay? Let's see, the next one, when a caret appears as first character inside the square brackets. Notice it's inside the square brackets, not outside like up there. It says it matches it negates the pattern, aka the pattern matches anything except ABC. So Z would match, pound symbol would match, et cetera, et cetera. So anything but that is what it's saying. You can do ranges. Make sure you're careful because A to 0 doesn't make much sense, but A to D, of course, makes sense. 1 to 7, of course, makes sense as well. If you put in an OR, that is a pipe. That should be shift right above your enter key and below your backspace key. Finds X or Y, or Z, sorry. It can match one or the other. And then if you just list it directly, finds X followed by Z. All right. Lastly, just a $, checks if the line in follows this regex, which is why the ending one is, which is why I'm sorry, finds regex much match the end of the line that works up here. But if you just want to match the end line, you can do $sign as well. Okay, any questions? All right, the next thing I'm going to show you, meta characters. Warning, these do not exist in Lex. Why am I showing you? Because most regex implementations do use these. Lex doesn't. These are just a shorthand.
It's flex.
No, not that. Last I tried. So backslash little d, any digit, backslash big D, non-digit, lowercase s, all the white space, all those white space characters, versus non-white. W's for any word. Notice that you can also have a digit in there. Big W's for the non-word.
Or is it an underscore as well?
Underscore as well, yes, you're correct. Underscore as well as part of the word. Thanks, C. Several non-space characters, and B as a boundary where matches a word boundary where a word character is. Okay, what's the difference between that and word? I'll get back to you on that one.
Well, I guess it's a boundary, so like it's the beginning or end of a word.
Yeah,
Space in between two words.
I don't see a space. I'm gonna have to get back to you on that one.
I guess.
I copy and pasted this
when,
one.
when there's a word with several word characters in a row, which is surrounded by non-word characters, it matches the first word character and the last word character in that word.
Oh, I see. That makes sense. Okay. All right. So the boundary, the end or the beginning, have to match that. Okay. All right. All right. Quantifiers do exist in Lex. This specifies how many of something. So you have your specifier of what characters, then you can follow by a quantity of how many of those need to exist. The clean star, or I like to call it the splat, 0 or more times. So keep that in mind. The star means 0 or more. Plus means 1 or more. Question mark means none or 1. So like a Boolean expression, it's either in there or it's not in there. Think of an optional flag to set. If you use curly brackets, you can put in X, which specifies the number of times that the order must exist. So backslash D for digit with 3 searches for 3 digits. Dot with Tim searches any character sequence of length 10. Has to be exactly that number. You can also specify a range by just putting comma and the end range. So backslash D 1, comma 4 with curly brackets means you must have a digit at least once and a maximum of 4 times. All right. Grouping are formed with parentheses and are really just markers for convenience. I think this is going to make way more sense when we go into examples. Just like if you were trying to do a Boolean expression in an if statement, you can do parentheses here. Okay. So let's write a regular expression that matches the input of yes or no. Here we go. I think examples will drive this home. Start with an easy one, and I'll give this one to you.
Yeah, that's.
Yeah.
All right, you got it? Any questions? Comments? Okay. All right, I'm going to be a little tricky. Okay, good. Make it uppercase. All right, yes sir. All right, all right. Anyone not with me except for poor Leroy? All right, someone write a regular expression for this. Oh wait, hold on. Y'all can write it in there.
We'll start with ABC
We had a drug test like at 6 o'clock in the morning, so I've been up ever since then. You study hard, right? I just had to make sure I didn't think
Richard's on fire today.
That's all good, dude. It was a good punch.
Morning. Welcome back.
I guess.
Yeah.
Or I mean, because we match other things as well.
Well,
No, I just say it matches that. It can match other things. It just needs to match. I will later go in. It has to match this, but not these. So I'm not. Oops. Which one? Okay, that's not going to work because that says it needs to be A, B, C, 1, and then either 0 or more 2s.
So
Oh,
either
okay.
ABC 1, 2, then a word character plus.
Okay.
Okay, so like this.
But yeah, it's plus because there's always going to be a character that.
So 1, 2, then it'll work. Oh, okay, yeah, that'll work too. Okay, that'll work. I found it helpful to stick with square bracket notation as much as you can because that helps group things together. Your answer is perfectly fine, by the way. It's not wrong. There are multiple good answers to this. But I came up with this one because it looks like it's any combination of lowercase characters and digits.
So I guess like the simplest way to group these is they're only lowercase letters and
Yeah.
images, but it can be a lot more combinations.
Yeah, and I would try and stick with the Lex notation since that's what you're going to be writing in. I showed you the meta characters because you're going to be seeing them out in the real world, but right now let's stick with this because it'll help you learn it. All right, how about, oops, let's go ahead and delete this one. All right, how about this? So it's, there we go.
Starts with a letter and then a combination of letters and lowercase letters and digits.
Okay, can you write that real quick?
Yeah, so carrots, and then I guess square brackets of a lowercase a to z, and then and then square brackets of lowercase a to z and 1 or the 0 to 9 star, and then
Okay. Yeah, I think you actually, did you read the slide?
No.
It sounded like you did.
but I mean, this is simple enough.
Yeah, it is simple.
So the plus here, do we really need it?
Yeah, you wouldn't really need the plus. That's true. The plus is actually not necessary. I just put it in there because that's the way I was thinking of it. Yeah, the plus is not necessary. You can take it out. You can leave it in. Doesn't really matter. Anyway, does everyone see how that regex works?
What does the plus do again?
One or more of these. So you have one or more lowercase letter followed by any combination of 0 or more of lowercase and digits. You doing okay?
Yeah,
All right.
I mean, thank you.
All right. There we go. Ooh, starting to get a.
Well, we can have the first 3 characters be whatever we want, and then the 4th one be a dot. And I believe we need to like backslash it.
Yeah, you got to backslash it. Well, I didn't talk about the escape, so yeah, this is actually a little mean of me. Or I just did that.
Yeah.
Anything, any amount of it followed by a dot at the end. So that backslash, remember since dot is a special character that can mean anything, in order to actually specify the dot in particular, you have to backslash dot.
You do that for spot too.
Yeah, yeah, and backslash.
Backslash would be like animal cheers.
Yeah. All right, here we go. I'm gonna let y'all do this one.
Damn, I just got that.
Mm-hmm.
You're still in your heart.
So square brackets CMF,
Mhm.
yes, and then AN.
Alright. All right, Tyler, why does Dan not match this? Go ahead, yes? Right.
Have CM right from the very beginning.
Right, so that square bracket CMF is saying has to begin with that.
That's what I said.
Yeah, it's totally what you said.
Just like my-
It just came from over there.
I threw my voice.
He threw his voice.
I recently.
Yeah, well, oh, nice, nice. All right, what we got? Right, that matches hog and dog and matches any word that has 3 letters, ends with OG, but does not start with a B.
So square brackets carrots B OG.
There we go. Because that carrot says doesn't start with B. Now,
So I guess square brackets, how capital A to Z, and then just yeah, anything. Well, not splat.
I guess anything that
Not
follows, yeah.
splat, but I guess.
I just did plus. You could do 2 as well if you wanted to, in the curly brackets. Yeah, afterward.
or even splat would work.
Yeah, it would work for this too. Yeah. All right. So we're going fast up here. How are you doing back there? Yes.
So how would this help with project 2?
We're getting there.
Okay.
I'm making sure. Regex is one of these things I've learned is easier to learn by example than trying to tell you the whole theory. So I am currently throwing examples at you left and right until you're tired of it. Are you tired of it yet?
Nope.
Not yet? Oh, okay. Hopefully I'll
Getting
succeed.
there.
Getting there?
We do get tired. That doesn't mean we skip the rest of the slide, the examples for that.
All right, let's see. Can man fan.
What did we do?
Did we go backward?
I think we did go backwards. All right, here we go.
Okay, WA Z plus.
Wait, does not match.
Oh, okay, so Z.
Wait, hold on,
Z
start.
and then Z plus. WZ then Z plus. would be-
All right. Did everyone catch that?
Whatever he said.
No.
He said something.
So as long as it has two Z's, so it doesn't match the single Z one, and then plus just however that accounts for.
Plus is one or more of the preceding. Preceding is a
Yeah.
single Z.
Okay, plus. Oh, okay.
WZ.
I didn't put any in brackets because it's not needed. But.
It's two Z's, and remember the second Z
Oh,
is 0.
true. Yeah.
Okay.
Is there another way to write this?
Of
What's another way? Of course there is. Yeah, there are tons of ways to do
Yeah.
it. What was that? What was the other?
curly braces.
You could do curly brackets, yeah. You could also put in a, instead of that plus, put in a third Z and put a star afterwards.
Fair enough.
So it'd be a. So it's 0 more of these Z's right here. You already specified 2 and then 0 more Z's. We don't need.
You just need to make sure it's at least 3 Z's and it's good.
Or 2 Z. Yeah, you're true. And then, oh yeah, so you could just do this.
We can just we can just say it has to have more. I think we don't even need the WA. We can
Anything
just
after
we
this
can
is
just
great.
dot star WA. No, dot star ZZ dot
Oh,
star.
that's true too. You could.
Oh my
That would match as well.
This is great.
Yeah, hopefully you see why regex can start going crazy.
You mean fun?
It is fun. I do enjoy it. It is fun. As long as people, hopefully at the end I'm going to tell you the difference between tokenizing and parsing. Regex is good for tokenizing. Don't do parsing. Every time I see someone in the workforce trying to parse with the regex, well, there's a little bit of blood boil going on, but I try and nicely tell them they're wrong. What?
This is so dumb.
Maybe not that bad.
This is dumb.
All right, here we go. It's starting to get a little more complicated. Write a regular expression that matches 1 file found, question mark, 2 files found, 24 files found, but does not match no files found, dot.
Here just has to start with a number.
I guess
Starts with a number and then anything.
dot star.
Yeah.
Dot star.
Yeah, so a number, a digit that follows by anything, or ends with a question mark.
Yeah. So it's not really complicated.
Another way, a little more complicated, but I think it actually matches more of what they're saying. It starts with some number of digits. For some reason, there's supposed to be a space that's in come out between the plus and the files. That S is optional, followed by another space that didn't come out, found, and then an optional question mark at the end. Or, I'm sorry, ends with a question mark. Has to end with a question mark, sorry.
So the two question marks have different meanings.
Yeah, they do, yeah, because the one with the preceding backslash means it has to be a question mark. That question mark means the S can exist there or not. And if for some reason on these slides, again, there should be a space in between the question mark and the F and that plus and the F. But yeah, the other way would work too. Write a regular expression that matches. Notice the white space. So it has to have white space.
With preceding so
Yeah, how do you write that?
does it like without the like yeah, without the things which aren't in legs, the white space characters, is there like a way to know the white space?
Solid brackets.
Just solid brackets?
You do solid bracket. Yeah, there you go.
Also,
So it
backslash
slides
space
the
is
space.
space.
Okay.
In solid brackets. It's very helpful. It's actually, when I do this, it's very useful to put things in solid brackets when you have a list and use them a lot. It just makes life easier.
Yeah.
So that's to start with some amount of white space. Backslash T is tab, and I also put in return and new line in there as well. Are there any questions on this one? Nope. All right. All right. Let's see.
Starts with a mission.
Starts with mission. Okay.
Mission call. And then just say mission
Well,
call.
it's all of these non-matching don't start with mission, so as long as you start with mission, it's all.
And right now with mission, all right, I should have put that one in there. But yeah, actually that makes it easier. Why does it have a not? Oh yeah, start with mission.
Yeah.
Oh, it needed a dot star at the end of it. It's missing one. Note to self, fix that. Whew. That ain't neat. Okay, here we go. Write a regular expression that matches file record, transcript.pdf file, and uses a group to capture the file name. Okay, remember the parentheses is going, the first set of parentheses is going to specify the file name, and make sure it doesn't match that. Do you understand what I'm saying? You're going to use a parentheses to group the part that is the file name.
Well, I mean, logically, it should end with the PDF, with the .pdf here.
Right. So that's, yeah.
You can basically have anything as long as it just ends .pdf.
So would it be dot plus, in parentheses, then .pdf and dots?
Oh, I think this is going to be a good one. Let's do this one. Let's see, where were we? Yeah, so what would it be? Okay.
But can the file be empty though?
Oh yes.
Found file name. Hold on a second. Let me write this out for you.
Yes, yes, plus.
Oh, are you saying?
So dot plus and dot start.
Oh, let me go ahead and make a new tab. Whoop, y'all can't see tabs. I just realized. Oh, I should make a make file. Let's make a make file. Well, I did find that, so that's cool.
Okay.
So you're let's see, so we need to find, what was it? File underscore, so I got file underscore record underscore transcript.pdf. Oh, I found that, and then you can't find, so test file underscore fake.pdf.tmp. Uh-oh. Oh, it found, but it didn't find the TMP. There you go.
Oh, because we need the dollar sign after the .pdf.
Oh, I'm sorry. Now you're in insert mode.
We change the starting class.
Yeah.
Okay. All right, let's try that. What was that? Test file underscore fake.pdf.tmp. Yep, didn't find it. But is it going to find everything else? Yeah, it's going to find that. Okay, great. The only last thing you really need to do, although in reality it should be this, because you want it to end with PDF. For example, if we had, let me show you why that's, if we had hello.pdt.pdf. Oh wait, it still ended with PDF, I'm sorry. Let me do that again. Hello.aaf. Oh, it didn't find it. Nice. So it did take care of that for you. Good. I usually like to be a little clear with my parentheses. But it looks like it went ahead and did that for you. Let me make sure that still works. Test fake. Perfect. All right. And what I'm saying with the parentheses is you really want it to be like that. Yeah, you want to group it. So now, I know it doesn't show you anything, but the point is that the first group is going to be the file name minus the PDF part. Okay, yeah, it does the same thing.
Wait, so does it mean no uppercase letters?
This one, oh, this one doesn't have, yeah, this one has, yeah, no uppercase letters. I didn't have any. So I could put in uppercase. The other one works as well for the given inputs. This is why you really need to be specific when you're telling what the regex needs to be, because as you can see, you can come up with different solutions that may or may not match everything that comes in. All right.
I love and then cats or I guess group cats or dots. Do we need to use parentheses too?
Yeah. This is why parentheses are now necessary. Because you need to know that it's this whole thing or that whole thing to tell Lex what exactly you're looking into. Because if you didn't have those there, it would be C followed by A or D followed by O. But with the parentheses, it's now saying this whole thing or that whole thing. All right.
I do love content models.
What's that?
I do love content models.
Wait, so do we not need two sets of parentheses here? C in parentheses and D over parentheses?
We could do it that way, but the parentheses work in this way. In this situation, they work. You just wouldn't know which way to expand it. Actually, I did that backwards. You're right, because if we didn't have the parentheses, it would try and I think it would actually try and match all of that or all of this. Is what's going on actually, yeah, which is something different. Yeah.
So the two sets.
No, this one will work. I pushed this one through a regex. I actually pushed my solutions through a regex. That mission one, I must have not copied my final submission over correctly.
So I guess it's gonna match C or D or not C A or D.
It's going to match either CA or DO.
So it's a bit counterintuitive here.
Followed by, of course, any.
Because if it doesn't just check the characters or groups before and after that, then when does it know? How does it know when to stop? Like, does it only stop at parentheses?
So it's a finite state machine. It's going to be very simple. Start with I space love space. Okay, parentheses. We got to evaluate this whole thing. CA or DO. So it's either going to have CA or DO followed by. So we have that followed by A through Z plus so one or more A through Z characters.
But how does it know not to do C and A or D then?
What do you mean?
Well, like when it evaluates what's inside the parentheses, how does it know that it should include all of the characters before the or?
That's what it defaults to. That's how OR works.
So from what an A or D we would have more parentheses like
Right. Right. Or you just move the parentheses to be around the A or D. And that would do it too. Okay. How are we doing? Make some sense? All right. let's go ahead and start writing something a little more useful. Write array expression that matches a variable named in C. Hopefully you remember what these are. Single letter. Can't start with a number, but can start with an underscore.
I guess caret and letter or an underscore, and then letters, numbers, and underscores start.
Any number of them. So 0 or more. So there you go. There's our first useful one. You can now parse an identifier or a variable name inside C++ with that regular expression. All right. How are we doing? Okay. That great? Let's go ahead and type that one in real quick. Let's see. So what I have A through Z underscore, and then A through Z, A through big Z underscore 0 through 9 star. Let me go ahead and put the. Doesn't even need the plus actually, but that's right. I'm sorry? It is a matter of habit. Because I'm thinking like it can start with any of these, followed by, okay, can only have that. It's just the way I think of it. So, variable name, but didn't find anything there. Okay, great. Okay. How about a number?
So we can just write the string except for a letter, or just a number, or
So so look at this now. I'm not saying it matches these and not that. I'm saying it matches decimal numbers. I'm giving you examples of decimal numbers to help you review, but I'm not telling you the whole list of things. So it needs to be able to match those and not see variable names.
also starts with an indefinite amount of numbers.
Okay, so let's start there. That's a good place to start. It is good to at least build them up. So let's start with 0 through 9. You said any number?
Yeah.
Okay.
Number, but before that, we can have a minus with a question mark.
Okay, hold on a second. Let me go ahead and print it out so we can see it. Let me go ahead and test it real quick. So 1, 2, 3, 4. Number found. Great. And then you said it could have a minus in front?
Yeah. And then, well, at some point, it's going to either have either end or have a dot and more numbers after.
Can you type it?
Well, we could do that maybe.
Okay.
0 to 9 plus.
All right. Oh, maybe I think I see what you're trying to say. And I think you're thinking, oops. It could be followed by that, right?
Oh yeah, that works. Yeah.
I think that's more of what you're, so now if we did 1, 2, 3, 4, it still found that number, 1, 2, 3, 4.567. It also found that as well, but if we try and do, that was a variable. If we try and do variable, yeah, so it tried and did number, yeah, so it actually parsed it as two different things.
So that means that we have to end it to have a dollar sign after this ends, and also wait, what was that?
I don't think you're an answer for that.
Now you are.
Okay.
How would you deal with a comma?
With a comma? Yeah, it did have commas.
Oh yeah.
It would be
Nah.
the same way you deal with
Oh.
the E.
I'm doing it the wrong.
Because it would have to be every 3 numbers as well,
All right, so,
away from decimal.
well, okay, let's see. I don't know if that's quite going to work out the way you want it to, but let's find out. That found out. Okay, it did. What about this? Oh, it just found variable P. There you go. All right, nice. Okay, and then, I'm sorry, your question was, what about commas? Because notice We have commas.
We just add that into the regex, right? Same
Right, we'd add it to the regex.
That would be before 3-digit.
Yeah, it'd have to be before the decimal dot. Yep.
So it couldn't start with it, but it
Couldn't start with a comma. Could start with, it can start with a dot, but we're not going to do that right now. Hopefully you're seeing that decimal numbers are actually kind of annoying.
Because in my mind, I just keep pushing it left, so it could be 3 and a comma, and then it could be 3 and a comma, and so on and so forth.
I still don't understand why it takes the letter bit, since like I don't see anything here that can match a letter. So like 720p, how does it even take the p from here?
Because it finds 7, it matches this, 2, 0, oh, it doesn't match this guy. All I can do is match this guy, this rule right here. So it's going to match those rules for 720, and then once it gets p, p matches this rule, so it's going to parse that.
Oh, but is it? Oh, so it's variable name found, not number found.
Yeah, it was variable name found, not number.
Okay, that makes sense.
I think you're doing this hard. What if you just add a comma to that first 0 through 9?
but then you could start with the comma, couldn't you?
Oh yeah, good point. All right.
So that's why I added the second one.
All right, let's see what that does.
Allowed a comma.
And I mean, it would probably take ages to actually perfect this. Well, maybe not ages, but it would take a while to
Right.
make sure that there aren't like there's a maximum.
Is this what I came up with?
three-
Oh, that was a simple one. I simplified it a lot. Because also realize there's an E.
Oh yeah.
Yeah, so in mine, it could start with a comma. Keep in mind, it can start with a dot, although this one allows a lot of dots, which is not right. But that's, oh well. Why? Oh well. Yeah, that dot shouldn't be there. Oh well. There could be a better one that would actually make sure you have a group of 3 digits followed by a comma as well. But I'm just trying to make this easy for now. So this is a good starting one. The official one is this. If I recall correctly, this is correct. Because you can't actually start with a plus. 0 through 9, any combination of that. They don't actually ignore commas in the, I think, the specification. If you follow it by a dot, you need 0 or more of those. Then you can have an E, because keep in mind the E is actually power, so it's times 10 raised to, again, you can have a negative or positive, any number of digits, and we're done. And that whole E thing is optional. Hopefully you can see the grouping in this one is extremely important, otherwise it's not going to work out well. It's a big one. But, you know, you copy and paste that into Lex, now you can parse numbers, right?
Sure.
As opposed to trying to figure this all out in code. Unless you were you all about that, Richard?
Not for this scenario.
Did I just say that? Oh, that would identify integers and decimal points. Ooh, I think I'm going to answer this one for you. Make the integer first, so that it will first parse the integer and then try and go into the decimal. Because remember, if you write an integer, it would match both of these regexes, because it would just match the beginning part of the second one. But since you listed the integer one first, it would parse and match that one first, and would not go on to the second one. All right. All right. What was the last one?
Wait, but in that one, wouldn't a decimal that starts with integers also match the integer?
Yes, but a decimal. Yeah. Well, hold on. Say it again. A decimal that.
Yeah, like would we need a dollar sign at the end? Because like if it's 10.5, for example, wouldn't it just take the 10 and save the decimal integer?
Lex always matches the longest pattern. So since 10.5 is longer than just 10, it would match the second rule.
All right.
Good question. Remember, those are the 2 rules. That's why those 2 rules are important. It always matches the longest one first, and then the priority of the equally matched ones is from top to bottom. All right, here we go. This one's fun. Match string literals over one line, aka those quotes. So it has to start with a and with quote. Okay, great. What's in the middle?
Oh, it can be nothing or it can be something.
Right. So
Yeah,
it's,
and also it cannot end with a backslash quote. So
sure.
like the character before the ending quote has to not be a backslash.
Correct. All right. Run a little on time, so I'll go ahead and give it to you. Notice how I used the square brackets a lot here. Sometimes it just makes it easier to read. Start with a quote. Then like, okay, I got parentheses, so I can have 0 or more of these ending with another quote. So 2 quotes, there can be nothing or something between it. It's either a bunch of not quotes or a backslash quote. So any combination of those inside of that.
Because if it's a quote without a backslash in the middle, it's also not a backslash.
Right. Yeah, exactly. Otherwise, it won't go. Okay. All right. How's everyone doing? Better with regular expressions now?
Better.
Better? All right. Okay. I'm going to take a step back now. I want to talk about when you should use Lex and when you should not. Lex and regex are good tokenizers. They are poor parsers. Parsers are for getting semantic understanding of something. Without a full compiler class, I cannot exactly explain the full difference, but let me try and put it simply. Take the example of HTML parsing. You could write a Lex tokenizer that would match some of them, aka that whole token. It would look something like that. That is not useful because you still have to now you have that whole token. Notice that over here in Lex, once you have that token, you have YY text, which is the string. But if you want to get the tag name, well, now you got to parse the string that you just have. So you kick the can down the road. It really didn't help you any. You see what I'm trying to tell you? So it's better to look at what the tokens are. Think of them as the atomic pieces of what you're trying to parse. What's the smallest unit that you're trying to parse? So you have the less inside signifies the start. Lowercase or uppercase letters could be the name of the tag or an attribute. Equal, we're setting an attribute. The value of the attribute inside of a string, that's full string literal we just went through. The ending of a tag, and then signifying is an end tag. What's important about this? You don't need to parse any of those tokens. They give you the information you need. You'll see what the difference is. Because I have seen plenty of regex expressions where they try and do all of this inside of that, and it is sad. Sadness, it's really annoying to deal with. But,
Really dumb.
yes. In other words, these are the tokens. Make each of those different lines in Lex. I'll call different functions so you can actually parse or make sense of what the code is. Do you understand what I'm trying to tell you here? Perry? No, really. Do you understand? Because this is might be confusing at first. Okay, maybe with the lab it'll make more sense.
Oh, there's a lab.
Of course.
There's a point to this?
There's a point to this?
Yes.
Actually, we should do things?
Now you have tokens. You can analyze what to do with them. Rule of thumbs: tokens should be atomic with regards to the information. So here's better examples. A token should not have multiple pieces of information. Take this example. Expression x equals y times 34. How many tokens do you see? 5, right. You got it. X, that's a variable. Y is, equals is a symbolic assignment. Y is another variable. Star is the operation, and 34 is an integer. So even though and then the space is ignored. We don't care about the space. We ignore the white space. But that's all that's telling you. Does that make sense? Those are the atomic pieces. It's not like you can break up y into smaller bits. You could try and break up 34 into 3 and 4, but that doesn't give you anything. So it's 34. How about another one?
As well, starting, sting, then a, ref, although,
This one is actually negotiable.
That's how
Yeah, so.
Depends on what you, yeah, that's my other point here, is it depends.
Would
That's
we
correct.
do A or graph in one, or multiple toolkits?
So how many did I say? I said 6. You could have less than A be 1. href should be its own. I think everyone would agree with that, as well as equal. You could try and break up the address, but generally if you're parsing HTML, you don't need, you just keep the address, someone else is going to deal with that later. So that's its own token. And then of course the ending one as well. Keep in mind your level of atomicness depends on your program or what you're trying to accomplish, yes.
So is regex used in browsers to actually parse the?
Oh, yeah. Definitely. All right, reading a file. I don't think you're gonna have to do this for your lab. That's fine. By default, Lex reads from standard in. To read from a file, simply set YYN equal to fopen the file name, passing an R, telling you that you're gonna read in text. If you get an error about undefined YYN, insert the following code before using YYN. And lastly, if you wish to parse multiple files, you need to set YYN and then reset Lex with the YY restart. So it clears everything it's done so far and we'll start parsing again. All right, everyone ready for your lab?
I've already done with it.
Nice.